In this video, I will tell you what is the method of Lagrange multipliers. This method basically gives us candidates points at which the minimum or maximum of a constraint optimization problem will occur. So, if I want to start, I should start with the point that, well, let us just go back to the regular optimization. So recall that in the regular optimization, we had this fact, AB, the point is a relative max or mean of a function f of xy if that point satisfies this thing. So if that point, if you plug in the first partial derivative of f with respect to y and x, at that point, both of them are 0. So these are, i.e., relative max means are critical points. So this fact from the regular optimization gave us a very strong tool when you're looking for local max mean, relative max mean of a function with two variables. Go ahead, find the critical points first, and then check those points. But this method, critical points of f itself may not even satisfy the constraint. So it means that it may not be part of the problem. So we cannot use regular critical points to solve. We cannot use them to solve constraint optimization problem. So we cannot do that. Okay, well, then what else we have? Well, this is where Lagrange comes in. He says that, so this is something that Lagrange discovered. He says that, well, if you're interested in finding relative max mean of a function, subject to solve optimization, constraint optimization like f of xy, subject to gxy, you need to find critical points of a new function, another function, a function which has three variables, x, y, and a third variable lambda, and it is defined by f of xy plus lambda g xy. So what basically Lagrange says is that, well, if you're looking for a solution for a constraint optimization problem, you can reduce it to finding critical points of a function with three variables. Well, this is a little bit vague. Let me just make the steps of such that method. So how does the method of Lagrange multipliers multipliers work. So how does it do? What steps we should take? Okay, so let's start from the beginning to optimize. So there's a function f of x, and there's a constraint gxy equal to 0. So to do that, we need to take these steps. Step 1, form the function f. Some people call it Lagrange function. So what is that? That's a function with 3 variables. And what do you do? So you have f of x, y. That's the function. You see, this is the function itself. Plus, there is a third variable lambda times the gxy of the constraint. That's the first thing. That's the first step. Step 2 is, well, find critical points of f. In other words, you have to find first partial derivatives of f. Well, this has three variables, so you have to find f with respect to x, f with respect to y, and f with respect to lambda, and set them equal to 0. Well, when you set them equal to 0, then solve it and find all a, b, and lambdas which satisfy the above equation. Well, when you have them, this is something that for this course you don't need to more much about, but usually you will get 1 or 2 points, and that will be enough. Then the points of the form AB. So just ignore the third variable in what you have found before. The points AB found in part 2 will give you the solution for the problem. Will give you the solution for the original constraint optimization problem. So it's 3 steps, but well, step 2 will need a little bit work. And let me write a few remarks here. Remark 1 is that, you see, f lambda. What is f lambda? F lambda, f lambda equal to 0 means what? We are differentiating this f with respect to lambda. You see, this f has two pieces, two additions. First part is f of xy. It has no lambda. So f lambda is basically 0 for the first part, plus the second part is just lambda times gxy. Yes. So gxy is independent of lambda, and then this is like 2 lambda. Derivative of 2 lambda is 2. Derivative of 3 lambda is 3. Derivative of gxy times lambda is gxy equals to 0, means that if lambda equal to 0 gives us the constraint, which is gxy equals to 0. So that's the first thing. So when you're trying to find the critical points, this last thing is not going to be anything new. It is just gxy equal to 0. And remark 2 is that although at the end we don't need the lambda, but to solve if x equal to 0 and if y equal to 0, try to eliminate lambda first. So use those ones, eliminate lambda, so you will have a new equation from these two, a new equation for only x and y. And then you put the third equation, which is the constraint itself, solve for x and y. So this is what basically you need to do. And very quick summary is that, well, method of Lagrange multiplier is a method which tells you where we can find solution for a constraint optimization problem. And it starts with the key point here is that everything happens in the critical points of this nice function f x y lambda equals to fxy plus lambda gxy. In the next video, I'll do some examples to explain a little bit more of this method.